Hi everyone, welcome to my YouTube channel. So today my topic for this particular video is the deployment of large language model on local machine. So in this video I'm going to deploy Llama 3.1 8 billion parameter model on my local machine, and I have the 16 GB RAM machine, so I'm going to deploy this large language model on my local machine. And Llama 3.1 basically released by the Meta. This is the open source model released by the Meta, and I'm going to use Ollama framework to deploy this large language model in my local machine, and I'm going to deploy this model in GGUF format. Basically, I have the CPU in my local systems. I don't have the GPU, so that's why I'm going to use the this 8 billion small model in GGUF format with Ollama framework. So in this video, mainly I cover deployment of Llama 3.1 on my local machine, and along with that I'm going to showcase you like how we can develop a end-to-end application. So I'm going to develop a chatbot by using this local LLM, and along with the local LLM I'm also going to showcase you to integrate a RAG system. So I'm going to cover a end-to-end application from uh, local LLM, then RAG system. In the RAG system, we have the chunking strategies and like the chunking mechanism and the vector database, embedders, query engine, like the retriever query engine. So I'm going to cover these all things in this particular video. And for web UI part, I'm going to use the Flask framework. So let me start. So to explain the local deployment and the RAG development, I'm going to use the content of one of my blog. So here are the blog. So in with the help of this blog, I'm going to explain each concept. This is the subject of the blog is the deploying Llama 3.18 billion on local systems with the help of Ollama, and to build a RAG power chatbot by using the LlamaIndex and Flask. So this one is the heading of the blog, and I will provide the link of this blog in the description of the video. Also, I will provide you the GitHub link as well. So all the detail will be in the description of the video. So let me start. So as I mentioned, like we need to a framework to deploy our model locally. So here basically I'm going to use the Ollama frameworks, and we have the different option. We can use the GPT for all. We can use the Python CPP framework as well for the deployment of large language model on the CPU part. So in this particular video, my focus only on the Ollama. So I will give you the quick introduction regarding the Ollama. So Ollama basically a open source solution designed to simplify the deployment part. So it's specifically for the deployment part and operational part on the local machine. And it basically a lightweight framework so that developer can easily develop an application by using the large language models, and it can support the CPU as well as GPU. So as per the requirement, as per the resources in hand, we can use the Ollama framework. And this model basically, sorry, this framework basically support the multiple model like the Llama 3.1, G4, Falcon, Clip, Lava. So here are the list. You can see here. This is the Ollama official website, and you can see here. These are the list of model like the Llama 3.1, 3.2. You can see here 5, 3.5, Mistral Small, Mistral Nemo, and Mistral Code Gamma, Code Command R Plus, Lava. You can see here. There is the huge list of the models supported by the Ollama framework. You can deploy any model as per your hardware configuration and your application requirement. You can use the any language model, or if you have the multi-modal requirement, you can deploy the VLM as well. So these are the models supported by the Ollama framework. And I will provide the link of this website also, Ollama official website, in the description of the video. And so as I mentioned earlier also, like it support both things like the CPU, GPU. If we don't have the GPU part, we can deploy our model on the CPU as well. But yeah, definitely in case of CPU, and if we have the limited RAM, like I have the 16 GB RAM, then we can deploy a small model or a medium size of models. And here are the basically the hardware requirement. Suppose if I have the 8 GB RAM, then I can deploy up to the 7 billion model, like the 7 billion parameter model work well on the 8 GB RAM. And if I try to deploy the bigger model like the 30 billion parameter size model, then definitely it go out of memory. And similarly, if we have the 16 GB RAM, then definitely we can go up to the 13 billion parameters. And if we have the 32 GB RAM, then we can go the 33 billion parameters. So there are the like the system requirements. So as per the system, we can deploy different models, and like as per the system, as per the hardware, and as per the our application requirement. So first things, I'm going to install the Ollama on our window machine. Ollama basically support the different operating systems like the Windows, Mac, Linux, Dockers. So, but in this particular video, my focus on the window only. So to install on the window part, so first we need to download the .exe, and here are the Ollama official website link. You can directly download the .exe here, and then you can install the .exe. You can run the installer, and it's very simple. You can like the easily install Ollama on your window machine, and Ollama basically run in background once the installation is done. So let me show you the icon of the Ollama in background. You can see here, this one is the Ollama icon. This way Ollama basically run in the background. You can see here. Yep, this one is the Ollama. And further, if you want to deploy Ollama on the Mac part, then first you need to download the installer for the Mac from the official website. And here are the link for the download the installer for the Mac part. And to install on the Linux, you need to run this curl command, and also the detail guide related to the installation of Linux. I have provided the Ollama official GitHub link here. You can refer to the here also. You can see here the detail instructions regarding the installation on the Linux part. And if you want to use the Docker to install the Ollama, then definitely you can install the Docker Ollama image from here. Here are the link provided, and this is the simple Docker command to run to pull the Ollama image. So this is related to the basic setup or Ollama installation. Once Ollama framework is set up successfully on our machine, then next step is to download the model. So here in this particular video, I'm going to download Llama 3.1 8 billion model. So you can directly download model on your local system. Just you need to open the CMD, and you need to run this command Ollama pull and the model name. Any model, like this is the list of the model. You can provide the model name, any model name, and the model is download on your local machine. So once the download is finished, like with this message like the success, you can see here, these are the logo of the one of the download which I done on previously I done on this machine. So once the download is completed, you can run your model locally with the help of CMD also. So in the CMD, you need to run Ollama run Llama 3.1. This is the model name. And if you download the any other model, then you need to provide the name instead of this Llama 3.1, those model name. And with the help of this command Ollama run and the model name, your model is running in inference mode on your local machine. And so I provide a simple query to this model hi, and this is the response of the LLM. You can see here, this is the response of the LLM, like the Llama 3.1 locally. So now my model is ready. My model is successfully set up on my local machine. The next step is to build a chatbot. And also to develop to integrate those chatbot with RAG system. So here are the code. This is the code related to our end-to-end RAG systems chatbot, and by utilize the Ollama model. So let me go to the Visual Studio Code to explain this stuff. And I will provide the GitHub link as well. So all the code link will be available in the description of the video. So these are the basically prerequisite, like as in the starting of the video I mentioned, like I'm going to use the Flask framework. So that's why the import related to the Flask library, then the LlamaIndex for the RAG part, and Ollama for the local model. So here basically I'm initializing my model Ollama, and then this function build sentence window index basically for to develop our vector database. So to develop a vector database, we require the documents. So first things is we need to document, we need to load these documents, then perform the chunking. Chunking basically here we are using the sentence window node parser. Instead of simple chunking method, we are using the sentence window node parser. And in the sentence window node parser, let me explain this part with the help of my another blog. So in this particular blog, basically I covered related to the sentence window node parser. So I will share this blog link also in the description of the video. So in this particular blog, I basically explain the RAG system in detail. So as I'm explaining you in the code, so we are using the sentence window retriever. So sentence window, basically sentence window parser is work in two ways, basically two main functions. First, it divides the document into the chunks, or you can say the sentence, and each sentence has the separate embedding, and then it basically generate the context window. And if we provide the size of 3, then it basically use the 3 sentence to develop these embedding window or context window. So let me explain with the help of this diagram. Suppose this is our document. First we need to load the document, a simple RAG step. So first we need to load the document, then we need to perform this chunking with the help of sentence window node parser. So these are the sentence. You can see here, this is the original document, and for example, these are the 5 sentences generated by our node parser. Then with the help of sentence window size of 3, instead of retrieving the single sentence, it basically retrieve the window of 3 sentences. So let me show you in detail. For example, if I ask a query to this retriever or this RAG system, what are the threats for marine system? So this sentence is the more relevant. As per the query, this particular sentence, red one, is the more relevant. But instead of retrieving single sentence, it basically retrieve the window size 3. So it basically consider the neighbor of this sentence. So this is the original sentence, more relevant sentence, and it basically add the neighbor sentence also, and then it retrieve the context. So this is the high level overview of the sentence window node parser. And to develop the sentence window node parser, we need to use the sentence window node parser from our LlamaIndex, and then we need to define the window size and the window metadata key, and then the original document, original text basically. And this is in the in the RAG part. We need to define these things in the chunking. So this step basically we need to add in the chunking. And second things, we need to add the metadata replacement post processor in the query engine, like in the retriever part. So here basically we importing the meta replacement post processor, and then we are providing the same Windows sentence node parser key here. So this way basically we develop our RAG systems. And let me back to our original blog related to the Llama 3.1 and RAG. So here basically in this part we are defining our chunker with the help of sentence window node parser, as I explained in previous section. And then we are basically setting this global variable regarding the LLM. LLM is the Llama 3.1 embedder, and the node parser is the sentence window node parser, and then storing our document in the vector database. So this basically, this function is loading our document, then performing the chunking, and then storing the data in the embedding format in our vector database. Then we need to define the retriever. So here basically we are defining the retriever. So in the retriever part, we are using the metadata replacement post processor related to the sentence window node parser and Reranker as well. So here we are using the Reranker as well. And this is the final RAG retriever. And then we need to integrate these RAG with our LLM or with our chatbot as well. So, and now here you can see here, first we are loading the document. So you can see here, first we are loading the document. Here basically we are loading our document in the vector database, you can see here, and then developing our RAG engine as a query engine, and then calling those query engine into our another function. So you can see here, and here are the two endpoint for to call our web UI parts to communicate to our web UI part. So this is the end-to-end workflow of our chatbot by using Llama 3.1 model along with the RAG system. And if you have any query related to the code, I also provide the code description. You can refer to this description as well. And if you have any query related to the RAG system, then I provide the link of my previous blogs. You can refer to these blogs also related to the RAG system. And I also provide the GitHub link. You can refer to the GitHub also. So that's regarding the technical part. So now I'm going to show you how we can use same chatbot through the UI part.
So this is the basically UI. So this is the app which we just developed during this video, and let me ask any query to this app. And this app basically take a few minutes to respond. This for same LLM we deploy on this machine. This is 16 GB machine, and all the setup running on this particular machine. That's why this machine taking the time. So you can see here, now our bot is responding. You can see here. So now our app is ready. We can use this app to develop any chatbot, any RAG systems. And definitely this is the beginning step. This is for the beginner part. And for the advanced industry level applications, definitely we can use the better approach. We can develop the end-to-end pipelines and also take care of the compliance and also the best practices. But definitely this is the beginning step.
So as you see, like our app is ready and our LLM is locally deployed, our RAG system also locally deployed, vector database also locally deployed. If you have the any requirement to develop application by using the private LLMs, local deployment of LLM, private RAG system, definitely you can take the help of this video and this flow. And these are the all code. You can see here all the code as I explained during the video. These are all the code in Visual Studio. This function related to the vector database of our RAG system. Then this for the query engine. Then this is for the LLM integration and all stuff. And this is for the front end and back end part. And these are the front end. This is the data we are loading in this RAG system. And further, I will provide the link of the GitHub also. So this is the GitHub repository related to this particular project. I will provide the link of this repository in the description of the video. So that's all regarding this video. So as I mentioned in the starting of the video, we cover the local deployment of Llama 3.1 model with Ollama framework in this video, along with RAG integration. In the RAG part, we cover basically chunking with the help of sentence window node parser, and also the retriever part from the RAG, and end-to-end chatbot in Flask framework. So these things we covered in this particular video. And please like and subscribe my channel. And thank you for watching this.